Assalamu alaikum. So today we're going to do the last video of Precalculus general review. So let's start with the first question. Suspension bridge has two main towers of equal height. A visitor on a tour ship approaching the bridge estimate that the angle of elevation to one of the tower is 21 degree. So when he was here, the estimate is 21 degree. After sailing 474 feet closer, he estimated the angle of elevation to the same tower to be 43 degree. Approximate the height of the tower. So here the first idea come to my mind here is I want to use tangent. So but I have a problem here. Trust me, I have a missing information because I don't know this distance, because the tangent is the opposite over the adjacent as long as I have the two angles. So I need to find out what's the x here, but in fact I don't need to. So I just need to see how can I create a system of equations, and I use substitution. So in that case I can solve for h. So let's start with this idea. So here the first tangent is I have tangent of 43, which is the opposite over x, which is h over x, opposite over adjacent. So which means that h will be x times tangent of 43. So the second triangle, so but the adjacent here is x plus here it will be x plus 474. So this will be my adjacent. So I have tangent of 21 is equal the opposite over the adjacent, which is x plus 474, which mean here my h will be x plus 474 times tangent 21. So I'm looking for h, not for x. So I need to do here, I need to solve x in terms of h. So here using the first equation, so as you see here we have system of equations which are known, h and x, but here I need to solve for h. I don't need to look for x, so I'm going to substitute. So I'm going to solve for x. X will be equal to h over tangent 43. So I substitute this x into the second equation. So my h here will be h over for tangent 43 plus 474 times tangent 21. So I'm going to distribute. I will distribute tangent, so I will have here h will be equal h times tangent of 21 over tangent of 43 plus 474 tangent of 21. So I'm going to move this h here and take h as common factor, so it's going to be h minus h tangent 21 over tangent 43 equal 474 tangent 21. So now take h as common factor. 1 minus tangent 21 over tangent 43 equal 474 tangent 21. Now I divide the whole thing by this expression, then I will get my h. So h will be 474 tangent 21 over 1 minus tangent 21 over tangent 43, and this will be my answer. So if I use the calculator here, I will end up having an approximation 309 feet. So this will be my approximation for that height. So this, if I use tangent, do we have any other choice shorter than that? Here we have the angle, so here I can have that angle too. So here let me get that one. This normally should be 137 because those two are supplementary angle. So the triangle is 180, so this will be 158, so it's going to be 22. So I can use the law of sine here. So let me erase the board and use the law of sine. So in that case, I think the law of sine will be shorter because it's straightforward, I believe. Alright, so what's the law of sine say? So if I have a triangle, whatever triangle is, and this is the angle A, this is the side A, this is the angle B, this is the side B, this is the angle C, this is the side C. So I know the sine of the angle A over the opposite side is equal to sine of the angle B over its opposite side, which is equal to sine of C over the opposite side. So how can I use this idea here? So here I have 22 has 474, so I have sine of 22 over 474 is going to be equal to sine of 21 over, and here I will name that side, which is the opposite, for example, y over y. It's going to be y, which means that if I solve for y, I will have, I just like switch this, move here, this move down, and of course multiply this one here, so it's going to be 474 sine 21 over sine 22. Now I'm going to use sine of 43, which is opposite over the hypotenuse, which is going to be h over y. So which means that h will be y times sine of 43. I already have the y, which is here, so I'm done with my work. Sine of 21 over sine of 22 times sine of 43, and again if I use the calculator I will get 309, which is the same as we got before. So either we use the tangent, which is straightforward but it's longer, or you can use the law of sine for that problem, so which will give you the same answer. Next question here. So suppose we have sine of alpha is 1/3, sine of a tangent of beta is 5 over 12, where alpha and beta are on the first quadrant between 0 and pi over 2, between 0 and 19. So they ask me to evaluate each one of those. Alright, so here I know that the formula sine to alpha is twice sine of alpha cosine of alpha. So this is the formula of double angle. So how can I use this information, because I don't have the cosine? So here I'm going to use a triangle. So this is my alpha, so this is my hypotenuse. So sine of alpha is the opposite over the hypotenuse, so that's mean 1 over 3. So which mean here if I want to find out the adjacent, so what I do, I use the if the adjacent is my a here, so I have a square plus 1 square would be 3 square. So as you see here is gonna be a square equal 9 minus 1, which is 8, so a would be square root of 8. So here it's square root of 8. So which means that the cosine of alpha, which is the adjacent over the hypotenuse, so it's going to be square root of a over 3. So I have my sine, I have my cosine, so I can find out my double angle. So sine of twice alpha will be twice sine of alpha, which is 1/3, times square root of 8 over 3. So which means that's going to be 2 square root of 8 over 9. So you can simplify this, so you move the 2 out, so because this is 2 times 4, it's going to be 4 square root of 2 over 9 if they ask you to simplify, because square root of 8 in fact is square root of 4 times 2. Square root of 4 times square root of 2, this is 2 times square root of 2, and 2 times 2 is 4. So that's what I did. Alright, next I'm looking for tangent of sine of alpha minus beta. So here I believe I will use the difference, sine of the difference. So sine of alpha minus beta is sine of alpha cosine of beta minus sine of beta cosine of alpha. So I have tangent of beta. So here I already have cosine of alpha, so here is the same thing. If I have 1/3 cosine of beta minus sine of beta, and cosine of alpha is square root of 8/3. So what's missing is the sine and cosine of beta. So here I'm going to use the triangle again. This is my beta. So we know the tangent of beta is the opposite over adjacent. So the opposite is 5, the adjacent is 12. So to find out the hypotenuse, because I need the hypotenuse to find the cosine and sine, so I'm going to use Pythagorean Theorem. So here is going to be 5 square plus 12 square equal hypotenuse square. This is the Pythagorean Theorem. So here I will have 25 plus 144 equal hypotenuse square, which is going to be 169 hypotenuse square. If I take the square root both sides, so we'll have 13, so this would be 13. So the cosine is the adjacent over the hypotenuse, so it's going to be 1 times adjacent 12 over hypotenuse minus opposite over hypotenuse. 5 is the opposite, hypotenuse 13, times square root of 8/3. So if I simplify here, I got 12/39 minus 5 square root of 8/39. So I can put it under one denominator, 39. So it's going to be 12 minus, if I simplify square root again, like I say, it's going to be 2 square root of 2, 10 square root of 2/39. So this will be your answer. I need to find out half angle. So the cosine of the half angle, so we know that cosine of double angle the cosine of double angle is in fact 2 cosine square of the angle minus 1. So if I substitute this by b, this will become b/2. So let me choose another variable, so in that case you will understand my idea. So if I use here double square, so this will be cosine square, 2 cosine squares, 2 cosine square of the square minus 1. So if I substitute this by b, so this is half of that expression. So this square is half of 2 square. You see, this rectangle is half of two rectangles. So if I name this one b, this one should be half of b or beta. So that's the idea. So if you know the double angle formula of cosine, so you can find out the half of the angle by using that concept. So here tell me that cosine of beta in fact is 2 cosine square of beta/2 minus 1. So in that case I got the formula how to find out the cosine of the half angle beta/2. So I know what is cosine of beta. I already find out this here. So we already find out which is 12/13. So I just need to evaluate the expression here. So let me use the top here to get my answer. So I know that cosine of beta is 2 cosine square beta/2 minus 1. So I'm going to move the 1 on the other side. So it's going to be cosine of beta plus 1 equal 2 cosine square beta/2. So I know that cosine of beta, which is 12/13, so 12/13, so it's going to be 12/13 plus 1 equal 2 cosine square of beta/2. So make common denominator, is going to be 12 plus 13 is 25/13 equal 2 cosine square of beta/2. Now I divide both sides by 2. So we'll have 25 over 26 equal cosine square of beta over 2. That takes square root. So when we take square root on both sides, I will have plus or minus. But which one I pick? So of course I'm going to pick the positive. Why? Because the angle is between 0 and pi over 2. If I do half of it, it's going to stay on the same quadrant, which is the first one. That means the cosine is positive, so I'm not going to use the negative one. So the answer will be cosine of beta over 2 is square root of 25 over square root of 26. So which is 5 over square root of 26. Of course, we're not going to leave an irrational number as denominator, so multiply both sides by square root of 26. Then your final answer will be 5 square root of 26 over 26, and this will be your final answer. Next question. So solve the triangle AB having side. Find all the angles to the nearest tenth of the degree. So here I'm looking for the angle of each, the measure of the angle of each angle of the triangle. Alright, so here let me draw. So always try to draw. In that case, you will make your life easier. So here this is A, this is 4 with the opposite, this is B, this is 2, and this is C, this is 3. Alright, so I need to look for the angle A and B and C. So here I don't have the measure of any angle, so which means I need to use first the law of cosine. You know what is the law of cosine? So the law of cosine states that the side A square, for example, is equal to B square plus C square minus twice BC cosine of the angle of A, which is capital A. So this is how to find out the A. If this is A, so I use the angle opposite to the side A. So here I have the value of B, C, and A, so I can find out the cosine. So I just need to substitute the value here. So it's going to be 4 squared equal 2 squared plus 3 squared minus 2 times 3 cosine of A. So in that case, I'll have 16 equal 4 plus 9 minus 12 cosine of A. So here this is 13, so it's going to be 16 minus 13. So 16 equals 13 minus 12 cosine of A. So now what I do here, I minus 13 both sides. So I got 3 equal minus 12 cosine of A. So divide by minus 12. So which means that minus 1/4 cosine of A. Cosine is equal to cosine of A. So I know that in if the cosine of A is negative, so it's an obtuse angle, so which means greater than 90 degrees. So here I know that cosine of A is equal to 1/4. This means that if I do the if I use the calculator here, I have A is 75.5 degrees, but I'm looking for obtuse. This is acute, so that's mean what I do here, I minus with 180. So here I will end up having 104.5 degree is the measure of A. Because this is negative, that means A is obtuse. So when it's obtuse, that means you have to solve for 1/4 cosine, find out the angle of cosine 1/4 by itself. Then take 180 minus the value you got, it will give you the obtuse one. Because here, if I use 1/4, that means I'm using the acute. So in terms of the circle, I want to show it to you in the circle. It works like this. So this is exactly what's going on here. This is what's going on. So here, this is my angle, as you see here. If I project that one here, This is my cosine. You see, this is my cosine of that angle. This is my 75. And here it will be my 105. So you see, this angle, they are the same cosine. This is, for example, minus 1/4. This one has minus 1/4, and that one again has minus 1/4. It has minus 1/4, both of them. So what you did here is you solve for that one without the sign. You get the 75 because those two are supplementary. You just minus 180 from 75, you get this angle. So it's exactly what I did. So my A will be 104.5. And one more thing, so which is something that you learn in elementary school, is that you have to check if this one square is greater than this one square plus this one square. That means this is obtuse. So if a square is greater than b square plus c square, that means this is obtuse. If a square is equal b square plus c square, this is a right triangle. If a square is less than b square plus c square, that means this is acute. You see, this is obtuse, this is right, and this is acute. That means this will tell me about the angle A. So if A is greater than, that means A is obtuse. If A is equal to, that means A is right. If A is less than, that means is acute. You can do the same thing with B and C. So it's the same concept. So those are the property we learn in elementary school. So you can do this one in your head. 16 is greater than 9 plus 3 plus 4, which is 13. So that means this must be obtuse greater than 90 degree. So keep in mind those information. They are very, very, very helpful. Alright, I got my A. So now I need to get my B. So here I'm not going to use again the law of cosine. So this is the law of cosine, because this is longer. So what I do, I'm going to use the law of sine. So sine of A over A is equal to sine of B over B. And I'm going to use again sine of A over A over little a equals sine of C over C. So in that case I will get my two angle right away. So sine of A, I know that sine of 104.5 over 4 equal sine of B over what is B is 2. So I just multiply both sides by 2 and I get my sine of B. Then I solve for that to get my angle B. So here I turn both sides by 2. So I got sine of 104.5 over 2 because I simplify here equal sine of B. So here if I evaluate this, I will end up having square root of 15 over 2. So here I will have so here I will end up having in fact I got after I substitute here, I got my B equal 28.9, which is the value here, and I do the same thing with the sine of C. So here I have sine of 104.5 over 4 equal sine of C over 3. So I multiply both sides by 3. So I got sine 3 sine of 104.5 over 4 equal sine of C. So after I use the calculator here, I got my C will be equal to 46.6 degree. So you can check the calculator here. Just take sine of 104. Keep in mind that sine of an obtuse is positive because it's still on the first and second quadrant. The sign is always positive. So here I will not have a negative sign. The same thing here because I'm using the same sign, which is sine of 104.5. Alright, so but you see, it's not because I got those values that means I'm done. No, I need to check something. If those are the exact answer, so how do I do that? So I need to add those three together, see if it's going to give me 180. So you have to check. So 104.5 plus 28.9 plus 46.6, and see if I will get 180. If I don't get 180, that means it's not. That means I make a mistake somewhere. So here I have 14, 20. So I get 2 here. So this is 10, 10, 20. So I have 2, 4, 8, 1. So this is 180 degrees. So the sum of those is 180. That means this will be 28.9 and this will be 46.6. Okay, please use the calculator and check the answer here. So you're gonna find out that this is 28.9 degree by using the inverse sine to get the angle for B and the inverse sine to get the angle for C. So I hope this one is clear. So let's move on to the next one. So here they ask me to solve a system of equations using quadratic here. So we have a quadratic system of equations. So here is straightforward. So based on my knowledge, so this is the equation of an ellipse and this is the equation of a line. So in fact I have an ellipse crossed by a line or not crossed. So it can be either of the lines, can be either it can cross, that means I will have two solutions, or it can be tangent, I have one solution, or it can be far away, there's no solution. So it can be one of those three cases, but the first one is an ellipse, the second one is a line. So when they give you ellipse and a line system of equations, that means they may intersect, they may not, and one of them may be tangent to the other. So here let's do substitution is the best way here. So I will start with the second equations. So I will have x plus 2y equals 7. So I will have x will be equal 7 minus 2y. So I'm not going to solve for y because I don't want to end up having fraction, because if I solve for y I have to divide by 2 and I hate fraction. So now I substitute this into the first equation. So I will have 7 minus 2y because this is x. So I'm going to substitute x by this. So it's going to be square plus 4y squared equal 25. So now I FOIL. Don't distribute the square. FOIL. Because some students they distribute just the square. No. So this is the same thing as 7 minus 2y times 7 minus 2y. And you FOIL. So it's going to be 49 minus 14y plus 4y squared plus 4y squared equal 25. Okay, so here I will have 8y squared minus 14y plus 49 minus 25 equals 0 if I move this one here. So now here I will have 8y squared minus 14y plus 24 equal 0. Divide the whole thing by 2 to have this number. So it's going to be 4y squared minus 7y plus 12 equals 0. So if I factor this, I can use the AC method. So I multiply this with this, so I will have y squared minus 7y plus 28 plus 48, sorry. So I'm looking for two numbers. If I tie them together, it's going to give me 48. If I subtract them, if I add them or subtract them here, yeah, if I add them will give me minus 7. So here it's going to be 48. So is there any way I can find out two numbers if I tie them together? make a mistake here. Yeah. You see here, when I multiply here, I got 14. I got 49 plus, I have 14 plus 14 is 28, minus plus 4 minus 28 plus 44 y square. So you see here, I make a mistake here. So this is why this will not give me anything. So I will have here 28. So I divide by 28, here will give me 14. Then here I think will work for me here, 14. So still I can divide by 2 more here. Alright, so if I divide by 2 here, so I get 2y squared minus 7y plus 3 equals 0. So here I will have, if I use the SC method here, I will end up having here 6 equals 0. So this means this is y minus y minus 6 times y minus 1. So this is what I will get here. So here it will become y minus 6 times y minus 1, because here I multiply this by 3 to get the 6 here, so I need to divide this one by 2 and multiply this side by 2. So I'll get y minus 3 times 2y minus 1 equals 0. So because I multiply by 3 to make it simple, but when I factor I need to do the inverse operation, which is divide the one which is multiple a multiple of 2 divided by 2. So here I divide this one by 2 and I times that side by 2. So you can check my video about factoring, so it will show you how to use the SC method to factor any quadratic expression. Now I make this one equal 0, which means that I will have y minus 3 equals 0, or 2y minus 1 equals 0, so which means that I will have y equal 3 or y equal half. Now I just need to substitute this value here to get my x. So when y equal 3, I got my x is 7 minus 6, which is x equal 1. When y equal half, so I will have x will be 7 minus 1, which is 6. So this means for x equal 1, y is 3, or I choose x equals 6 and y is half, and this will be your answer. And this is you can check this one here. So if I substitute 3 here, I got 6 and 1, so it's going to be 7. If I substitute half here, it's going to be 1, and if I put 6 here, it's going to be 7, which will give you the same answer here if you substitute. So I hope this is clear, and be careful. You see, we can make mistakes, so be careful. So I try to use a shortcut which is in my head, but I forgot to multiply the middle one by 2. So please, when you FOIL, make sure that you make the right addition. Next, so here they ask me to graph y equal to sine minus 1. So here I need to find out my amplitude, which is the coefficient of sine. So the amplitude here is 2. And the period here is 2 pi. So period is 2 pi divided by the coefficient of x, which is 1. So it's going to be just 2 pi. So what I do here, this is my period. They already give me the graph. So here this is my amplitude. I have 2 and minus 2. This is my period. So what I do, I divide the period into 4 equal pieces, and it's already done. So first I'm gonna draw 2 sine of x. So this is what I do first. I draw 2 sine of x. Then the minus 1 is the shifting, which is vertical shifting. So I'm going to shift it vertically down by 1. So first thing I will draw this. So this one starts from 0, move to 2, cross 0, go down to -2, and go back to 0. So it's going to look like this. Sorry for the drawing, but just give you the idea. Now after you do the drawing, so this is what's easy here is you can drag this one down by 1 unit. You see, this is exactly what's going on. You drag it by 1 unit, so this will be on the -3, this will be on the 1, and this will become here. So this, the second one, is your, now this is the graph of 2 sine of x minus 1. So of course you're gonna draw the same graph down the same way when you shift it down. So you cannot do that option because this is not on the paper. Okay, but I hope you got the idea. Alright, so let's move to the next question. Here we have cosine, but we have a minus. That's why I'm going to flip. So first I will draw cosine to x, then I will flip about the x-axis. About x-axis. Okay, so first thing, let's draw this. So here my amplitude is the coefficient of cosine, which is 1. So it's going to be just 1. And my period is 2 pi over the coefficient of x, which is 2. So it's going to be pi. So this is my pi. So what I do here, I divide this period into 4 equal sides. So that means this is pi over 4, and this is 3 pi over 4. We know that cosine starts from 1. Yes? So it's going to start from 1, move down to 0, then go down to -1, move up to 0, and go up to 1. Okay, there we go. So here will be here. So this is exactly how we gonna draw this. So what I do, so I'm gonna draw this one here. So it's like curve here, go to 0 and move up here. So now I'm gonna flip this about the x-axis. So I'm gonna flip this one about the x. So what I do, I flip it. So let me use my flipping tools. So I just flip this one here. There we go. Just need to flip the graph, and you're gonna get your graph when this is the final graph for minus cosine of 2x. So I hope it's clear. You just need to flip it about the x-axis. This is the purpose of the minus. First you draw this as you draw regularly, then you flip it about the x-axis because of the minus. Alright, next question. So here I'm gonna draw a polar coordinate graph, and let me show you the easy way how to draw it and make you understand the concept. So here I create a row or an arrow. So this is gonna be your guide. So in fact this is exactly how we draw it. What I need to do is just need to rotate this about this. So each time, this is my ruler, it has the value. So this is the positive side, this is the negative side. So this is the first from here to here. I will name it here. This is 1, 1, 2, and the last one is 3 here. So this is the same thing for each one. This is 2, this is 1, and this is 3. So on each line it has the same measure. So what I need to do here, I need to rotate this ruler, and based on the angle I will find out the measure of the radius. So r, which is the radius, depend on the angle. So that's mean r equal to cosine theta. So the value of the theta will give me the length of the radius. So for theta equals 0, so for theta equal 0, I will have r will be 2 cosine of 0, which is 1, so it's going to be 2. That means the first point will be here. This is for cosine of 0. Then what I do next, I'm gonna rotate by pi over 6. I'm gonna say, okay, what is cosine of pi over 6? If I have theta equal pi over 6, so r will be 2 cosine of pi over 6, which is 2 times square root of 3 over 2, which is square root of 3, which is 1.4, something like that. So that estimate is square root of 3 is 3 plus 4, 7 divided by 4 is 1.7, so it has 1.7. So let's assume 1.7 is here. As you see here, I'm not going far away. You see, now this in my rule 1.7 is here. I'm assuming is here. Then what I do next, I rotate to pi over 3. Pi over 3 is half, so theta equal pi over 3. That means r will be 2 cosine pi over 3, which is 2 times half, which is 1. So that means my point here for pi over 3 will be at 1. You see? Now I'm gonna rotate my rule. Cosine pi over 2 is 0, so that means the radius will be here, is 0. So as you see here, if I draw, what I will get half of a circle. But I'm gonna keep going because I want to show you something. Now I'm gonna move to the next one. Here the cosine will be negative. You see, the cosine here will be negative. So for theta equal to pi over 3, so cosine is r equal 2 times cosine of 2 pi over 3, which is negative half. 2 times negative half is minus 1. So where is the location of minus 1 here? You see, this is the positive of the ruler. This is the negative. So that means the minus 1 will be here. As you see, the minus 1 will be here. And if I keep rotating, I will end up having the same location for the rest. So this means here I will end up having that point here, because 5 pi over 6 is going to be minus square root of 3 over 2. So if I rotate here, I will have the point at minus square root of 3 over 2. So it's going to be minus square root of 3. So it's going to be here. And when I make it to 180, if I make it to 180, if I make it to 180 here, so it's going to be minus 2. You see, this is the minus 2 is going to be here. Now I have my points, so what I do, I connect them, and this look like a circle. So what I need to do here, I take off my ruler from my graph, and I connect those points. So it's going to look like a circle. So let me try to make it perfect as a circle. But this is in fact a circle with center 1. So this will be a distance from here to here is 1, and distance from here to here is 1. So it's not the perfect, but this is exactly what you should end up having, a shape like this, and it's a circle. So we can find out the equation of the circle using the coordinate. So here, so I hope it's clear how to draw a polar coordinate graph. It's not that hard. As you see, you just need to create a ruler and keep rotating the ruler based on the angle. Choose the middle of the radius you find out based on the angle you rotate the ruler. So how do I know if it's a circle or not? So let me show you how to do this. So I know that r is 2 cosine theta, and we know that x in fact is r cos theta, and y is r sine theta. So if I multiply both sides here by r, so it's going to be r squared. Yes, this means I will have r squared equal to, and this is my x, because x is r cos theta. So r squared in fact is x squared plus y squared is r squared. I substitute this one by x squared plus y squared equal to x. So here I move the 2x on the other side, so x squared plus minus 2x minus 2x plus y squared equals 0. So I'm going to add 1 both sides. So we end up having 2x squared minus 2x plus 1, which is a perfect square of x minus 1. So it's going to be x squared minus 2x plus 1 plus y squared equal 1. So this is the same thing if I have x minus 1 square plus y squared equal 1. And this is the equation of the circle with center 1, 0 and radius 1. And this is exactly what we got. This is 1, 0, the center, and the radius is 1. So this is for you to check if your graph is the exact graph for that function. Alright, next question here. So solve the following. So here they ask me to solve those trig equations. So here they ask me to solve for this equation on 0 to pi. So here I have 2 square root of 3 cosecant of x equal to, so square root of 3 cosecant x plus 2 equals 0. So I'm gonna minus 2 divided by square root of 3, so it's gonna be cosecant x equal minus 2 square root of 3. So I know that cosecant is sine, so it's gonna be 1 over sine x equal minus 2 square root of 3. So if I flip this, I will flip this. That means I will have sine of x equal minus square root of 3 over 2. And we know that minus square root of 3 over 2 of sine is minus sine pi over 3. So it's going to be sine of minus pi over 3, because sine of pi over 3 is square root of 3 over 2. So in the circle, pi over 3 is here, and you see this is pi over 3, and it's almost like near to 1. So now I have my sine. So I know that if I have sine of x equals sine of a, that means x will be either a plus 2k pi, or x will be pi minus a plus 2k pi. So this is how we solve sine using the circle. Why? Because here if I project this one here, you see this is a and this is pi minus a. So as you see, they share the same sign. So this is my sine of x, so either for a or pi minus a. So but the 2k pi just mean the coterminal angle, because if I do a full rotation again, I will have the same angle. This is why we use the 2k pi here. So here I will end up having x equal minus pi over 3 plus 2k pi, or x equal pi minus pi over 3 plus 2k pi. So which means that I will have here pi plus pi over 3, which is 4 pi over 3 plus 2k pi. But here they ask me between 0 and 2 pi. That means here is general solution. So when they ask me for 0 and 2, between 0 and 2 pi, that means I choose k equal 0 for the 0 and k equal 1 for the 2 pi, and I plug in those two into both answer here and here, and check which one is less than 2 pi. So if I plug in 0 here and here, I will end up having minus pi over 3 for pi over 3. So this is out of the range because this is negative, so I will not take it. If I plug in 1 here, I will have minus pi over 3 plus 2 pi, which is going to be 5 pi over 3. And if I plug in 1 here, it's going to be out of the range of 2 pi. So if I plug in, I have 4 pi over 3 plus 2 pi. You see it's out of the range, so I will not take that value. but I will take that one. So the two answers we have are 4 pi over 3 and 5 pi over 3. So this for A is 4 pi over 3. The angle X can be equal 4 pi over 3, or X is 5 pi over 3. So those are the two angles for the first question. So I hope you get the idea and how we come up with this solution. Always start with the general solution, but if they give you a limit of the interval, if they start from 0 to 2 pi, that means k can be 0 and 1, then you choose which one is between the 0 and 2 pi. If between 0 and 4 pi, that means you choose k to be equal 0, 1 and 2, then you try 0, 1 and 2. If between minus 2 pi and 2 pi, that means you're going to start with minus 1, 0 and 1. So it depends where the question. Here they find you all the solution, that means the answer should be look like this at the end. So let's me do the second question. So here we have tangent square x minus 3 equals 0. So I'm going to factor this. So this is the same thing as tangent minus square root of x times tangent plus square root of x. You can use that idea, tangent square of x equals 3. Then you take square root, so tangent of x will be plus or minus square root of 3. You can do it this way, which is more easier, or you can factor and make each one equal 0, and you're going to end up having the same idea, tangent equals square root of 3, or tangent of x equal minus square root of 3. If you make this one equal 0 and you make equal this one equal 0, you can end up having this solution. Now I need to find out which tangent give me square root of 3. So I know that tangent of pi over 3 give me square root of 3, because sine of pi over 3 is square root of 3 over 2, and cosine pi over 3 is half. So if I do sine over cosine, I will have square root of 3 because the 2 will cancel out. So here I know that tangent pi over 3 is my key here. So what I do here, I change square root of 3 by tangent, so I will have tangent of x equal tangent pi over 3, or I will have tangent of x equal tangent of minus pi over 3. So those are my substitution for square root of 3 and minus square root of 3. So for tangent, so we know that tangent will be, so if I do the tangent here, so this is the line of tangent, and if I have pi over 3, so suppose this is my pi over 3, and if I extend this line, you see, so this is my pi over 3. So the pi over 3 and pi over 3 plus pi, you see, from here to here is 4 pi over 3. They have the same tangent. Is that clear? So that's meaning you're going to have x equal pi over 3 plus k pi plus 2k pi, or pi plus pi over 3 plus 2k pi. But most of the time we use tangent, this form. So we said to do 2k pi, we do just k pi, so because each 180 degree they have the same value. So x will be equal pi over 3 plus k pi. So this combine both equations, either x equal pi over 3 plus 2k pi, or x equal pi plus pi over 3 plus 2k pi. So just this answer combine those two. So we don't use those two, we use this one. And here I will have the same thing. I will have x equal minus pi over 3 plus k pi. So those are my final answer. So I don't have to use this, because those two are combined in one answer here. So for B, I will have x equal pi over 3 plus k pi, where k is any integer, or x equal minus pi over 3 plus k pi, or you can use plus or minus here to use only one line if you want, so it's up to you. you can do that notation if it can be accepted by your professor. So this is what we need to do for the second equation. So the third one, so let's do the third one. So the third one, we have cosine of 2x plus square root of 2 sine of x equal 1. So here I have sine, I have cosine, but I know that cosine 2x can be written in sine because based on the double angle formula, I know that cosine 2x is 1 minus 2 sine square of x. And I have cosine of 2x is 2 cosine square of x plus 1. Plus 1 or minus 1? Yeah, minus 1, not plus 1. No, I think it's plus 1. Because I know that this is cosine square x minus sine square x, and this is 1 minus cosine square. Yes, is minus 1. So either that one or that one, but here I don't have sine, I don't have cosine here, so what I do, I'm going to substitute this one by sine. So here it will become 1 minus 2 sine square x plus square root of 2 sine x equal 1. So here it's like I have a quadratic equation. So let me move everything on one side. So I'm gonna minus 1 here, minus 1 here. So this one cancel out, this one cancel out. I got minus 2 sine square x plus square root of 2 sine x equals 0. I have sine as common factor. Sine x is minus 2 sine x plus square root of 2 equals 0. So the product of two numbers is 0. That means one of them is 0. So I'll do this, or I do minus 2 sine of x plus square root of 2 equals 0, which means that x can be any k pi. So it can be 0, pi, 2 pi, 3 pi, and so on. Or I will have, I switch those two, so I will have 2 sine x equals square root of 2. That means I will have sine x equals square root of 2 over 2. And this is the same thing as sine pi over 4. And we know that we just did sine, so I will have x either equal pi over 4 plus 2k pi. So either x equal pi over 4 plus 2k pi, or x equal pi minus pi over 4 plus 2k pi. So like I say, either the angle, like you see the angle A, or pi minus A for sine, they share the same sign. A, pi minus A, they share the same sign. So either pi, which is my A, pi minus A, which is pi minus pi over 4, they share the same sign. So here it's the same thing as 3 pi over 4 plus 2k pi. So here they limit my domain. So here I'm going to choose k equals 0 and k equal 1 for that one. Here the same thing here. So for k equals 0, I have x is 0. For k equal 1, I will have x equal pi. I cannot choose 2. Why? Because 2 is not included. So those are my first solution. And here I do the same thing here. For k equals 0, I will have pi over 4. So for the second case, I will have k equals 0, I will have x equal pi over 4. If I choose k equal 1, it can be greater than 2 pi, so I will not add 1 here. Again here, if I choose k equals 0, I will have 3 pi over 4. So k equals 0, here I will have 3 pi over 4. If I choose k equal 1, it's going to be above 2 pi, so I will not choose that one. So those are my 4 solutions for the third equation. So C will be x equal 0, or x equal pi, or x equal pi over 4, or x equal 3 pi over 4. Those are my 4 cases. So I hope it's clear. Here they give me a vector space, so they give me a vector, so u is minus 5, 4, and w is 1 minus 1. So here they ask to find me the absolute value of u. So if I have a vector that has coordinate a, b, so the absolute value of u in fact is the same thing as finding the hypotenuse. square root of a square plus b square. Keep in mind, in the vector space, if I use in vector, so when we create the vector here, it's a point, but we create a line which is the hypotenuse if I use in terms of triangle. So the projection here, it has the length of the y. Let me use another color. So this projection has the length of y, and this it has the length of x. So this means here it's my y coordinate and this is my x coordinate. So this value for our case here is a, and this is my b. And that means if I want to find out the absolute value, that means they ask you to find out the length of the vector, which is in fact in that case is my hypotenuse. So and to find out the hypotenuse, I use Pythagorean Theorem. So a square plus b square, it will give me the hypotenuse square. But they look only for the height, so I'm going to use the square root. So which is I'm going to use here. So absolute value of u here is going to be the square root of x squared, which is minus 5 square, plus 4 square, which is square root of 25, plus 16, which is square root of 41. So this is for the first one. For the second one is operation. So I'm going to use the concept of addition, add similar terms. So I'm going to add the one with the one. That means the first coordinate with the first coordinate, the second coordinate with the second coordinate, the third coordinate with the third coordinate, and so on. Here, if I have 2, that means I'm going to distribute first. So I have 2 minus 5, 4, minus 3 times 1 minus 1. First, I multiply, so I distribute this one here and here. So I got minus 10, 8. And I distribute this one here and here, so it's going to be plus minus 3, 3. When it's with the minus here, I will have, if you don't distribute the minus, we have to keep the minus here. So either you do it this way or you do it that way. It's going to be minus 10, 8, minus 3, minus 3. So if I don't distribute the minus, so I just multiply 3 with here and here. But I will get the same answer. So here I will add this with this and add this with this. Here I subtract this with this and I subtract this with this. So here I will have minus 10, minus 3. As first coordinate, and 8 plus 3 as second coordinate. Here I will have minus 10 minus 3 as the first coordinate, and 8 minus 3 as minus 3 as the second coordinate. Here I will have minus 13, 11, and here I will have minus 13. Minus must become positive, so it's going to be 11. So this will be my second answer here. So we put the first one here, square root of 41. Second one will be minus 13, 11. And here we have dot product. Dot product just means you multiply the first coordinate with the first coordinate plus the second coordinate with the second coordinate. So this is the dot product. If I have u and we have v is c, d. If they ask me to do the dot product, so u dot v, we do the first times the first, a times c, plus b times d or d times b, it doesn't matter. So this is the dot product. So this means I will have minus 5 here for u dot w. So I will have minus 5 4 dot 1 minus 1. So I do minus 1 times minus 5 times 1, which is minus 5, plus 4 times minus 1 is minus 4, so it's going to be minus 9. So the answer here will be minus 9. Here, suppose a vector with the magnitude 150. So let me use this one. So this is 150. This is my vector, and is inclined to the right and upward. So like the same thing we did here by 52 degrees. That means here is 52 degree from the horizontal. Resolve the vector into component. So I need to find out the x coordinate and the y coordinate. So here I'm going to use the cosine and sine. So that's the only way I can get the component, because I know that if cosine is related with the hypotenuse and sine is related with the hypotenuse. So they give me the hypotenuse only, so I'm going to use cosine and sine. If they don't give me the hypotenuse, they will give me one of the sides, so I'm going to use tangent. But here they give me the hypotenuse, so I'm going to use cosine and sine. So I know that cosine of 52 is the adjacent over the hypotenuse. So that means x will be 150 cosine of 52. So you just need to use calculator here. And for the second one, sine of 52 is the opposite over the hypotenuse, which is y over 150. That means I will have y will be 150 sine of 52. So if I use the calculator here, I will end up having 92 pound, and here I will have 118 pound. If you take this one square plus this one square, will give you 150 square. So I hope it's clear. So let's move to the second question. Here they ask me to find out this complex number in standard form to the power 4. So here I will use the short way. In fact, there's a different way how to do this. So I will show you this way, I'll show you another way, so and you choose which one you want to do. So I use the regular way, which is the multiplication way. So I have minus square root of 2 plus square root of 2i to the power 4, but I use it in short way here. So what I do here, I split it in this way. Because this and this are the same, so if I find out that one, I can just do the same thing for that one. So here I do the perfect square here, so it's gonna be 2 this one square plus this one square, which is gonna be minus 2 plus twice this time this twice this time this, so it's gonna be minus 4i. So let me do it step by step, so in that case you will understand what I'm doing here. So I multiply this by this, so it's going to be just 2. Multiply this by this, so it's going to be minus 2i. Multiply this by this, it's going to be minus 2i. And when I multiply this with this, so it's going to be plus 2i squared, which is minus 1. So it's going to be minus 2 and 2 cancel out, which is what we got here. What's left is minus 4i. This is minus 4i. This means this is minus 4i, which means here is minus 4i too. So at the end you end up having what? 16i squared, which is minus 16. So this will be your answer. The short way is you change this one to exponential notation. I don't know if you gonna learn this or not, but let me show it to you. Here I need to change this one to exponential notation. So I know that square root of 2 over 2 is cosine of pi over 4, and the same thing as sine pi over 4. So it's the same thing. So I know that e to the angle I theta in fact is cosine of theta plus I sine of theta. So this is the idea of I'm going to do exponential notation of complex number. This is the exponential notation of a complex number. So here I divide both sides by 2. I multiply the whole thing by 2. So I will do this minus square root of 2 plus square root of 2i to the power 4. Is the same thing if I divide this by 2, I multiply the whole thing by 2. So I will have minus square root of 2 over 2 plus square root of 2 over 2i times 2 and the whole thing power 4. You see, if I distribute the 2, I will end up having the same thing here. So what I do, I distribute the 4 here. So, but I will change this one to cosine, and this is sine. So it's going to be minus sine minus cosine of pi over 4 plus sine pi over 4. This is I. So 2 and the whole thing to the power 4. So this one is the same thing if I have 3 pi over 4, because 3 pi over 4 give me the minus cosine, and sine will be the same thing as sine pi over 4. Sine of pi over 4 is the same thing as sine of 3 pi over 4, but cosine of 3 pi over 4 is minus cosine of pi over 4. So that's mean here is the same thing if I have cosine of 3 pi over 4 plus sine of 3 pi over 4 I here, and this is 2 to the power 4. So now I can change this one to exponential notation. So it's going to be e to the I 3 pi over 4, because this is going to be my theta, times 2 to the power 4. So if I distribute the 4 here, I will end up having e to the I 3 pi times 16. So as you see here, if I rewrite this one in terms of cosine, so it's going to be 16 times cosine of 3 pi plus I sine of 3 pi. Sine of 3 pi is 0, so this is gone. And we know that cosine of 3 pi is minus 1, so it's going to be minus 16. So this is minus 1. And as you see here, is minus 16. So you can do it either that way, using the exponential, or that way.